Hello students, welcome once again to our YouTube channel. So that was the question for today. The question is of definite integration, as you all know it. See, why I picked up this question for discussion, because see, of course it involves definite integration, it involves box bracket. It's not mentioned here, but it's understood that this is GIF, okay. And one more thing I will like to stress on it here. Until unless mentioned in examination, in any paper, when you are taking like JEE examination or any other examination, until unless mentioned, we never consider box bracket to be GIF, okay. But here the purpose of this question was to take care of this part also, the GIF function also, okay, and along with that solving a series also. That's very important aspect of this question, okay. Let's start. See, x belongs to 0 to 1, okay. Now 1 by x will go from 1 to infinity, okay. So there's a huge range. I mean, how to start with it? So we can say that 1 by x will belong to 1 to infinity. So let's start in that way only. So for that, so therefore greatest integer of 1 by x, what will that be? That will be 1 if 1 by x goes from 1 to 2. All of you agree or not? Similarly, I can write here greatest integer of 1 by x will be 2 if 1 by x goes from what shall I write, greater than equal to 2, less than 3. Similarly, it's 3 if 1 by x lie between 3 and 4, okay. And now see, if 1 by x lie between 1 to 2, doesn't that mean x belongs to 1 by 2 to 1, bacho? Since x is positive, okay. Similarly, if 1 by x lie between 2 to 3, doesn't that mean that x belongs to 1 by 3 to 1 by 2? Likewise, here can't we say that x belongs to 1 by 4 to 1 by 3? Isn't that? So of course we'll keep closing the ends here. So like this, we will keep on closing the end here. So this is how it will go on. Now what does that mean? See, we will be starting from half to 1 and move in reverse order. So I will write this integral as, so therefore I will write my integral as half to 1 to start with, half to 1, and this is let me write it, check it here, yeah. So this is 1 by 7 raised to the power box of 1 by x, and box of 1 by x is going to be 1 here. So it's just 1 by 7 dx. Then I will go from 1 by 3 to 1 by 2. 1 by 3 to 1 by 2. So x is between 1 by 3 to 1 by 2. Box of 1 by x is 2 there. So this is integral of 1 by 7 square dx. Similarly, you go on and go on. 1 by 4 to 1 by 3, it will be 1 by 7 cube dx, and see, there will be infinite many terms. Why? Because the interval, the size of this interval between upper limit and the lower limit is going to it will get on reducing as you get closer and closer to 0. So you have infinite many such interval, infinite many such integrals, okay. So now let's solve it. So it's 1 by 7 integral of 1 with respect to x is x, and x goes from half to 1, so it's 1 minus half. Isn't that plus? Similarly, it is 1 by 7 square into half minus 1 by 3 plus 1 by 7 cube into 1 by 3 minus 1 by 4, and so on till infinite many terms. Now that's the second aspect of this question. As I said in the beginning, the another aspect is a series. So how to solve the series? So I believe that many of you must be knowing it, how to solve such a series. See, this is neither AGP, this is I will say this series is not in any standard form. There is no standard form in that chapter of sequence in series to which we can match it and then use any method to solve it, okay. So I will say collect all positive terms together. Half into 7 square plus 1 by 3 into 7 cube, and so on. This is one series. Similarly, minus times collect all negative terms. So it's half into 7 plus 1 by 3 into 7 square plus 1 by 4 into 7 cube, and so on. Okay, now let's come to the important aspect here. and that is the series of log ln 1 plus x बच्चों. So what's the expansion of this series? This is x minus x square by 2 plus x cube by 3 minus x raised power 4 by 4 and so on and so on. See, when should this series strike our mind? This series should strike our mind when in denominator you have simple natural number 2, 3, 4 consecutive numbers along with some like consecutive powers, or power can be managed, but 2, 3, 4 in the denominator. But then you can say that here we have alternate positive negative sign with here in the first series we have all positive terms, and in second series we have all negative terms. How will we manage it? So of course we know how to manage it. And how are we going to do it? We will say, okay, in that case consider the series of ln 1 minus x. So it will be minus x square by 2 minus x cube by 3 minus x raised power 4 by 4 and so on. So this can be written as minus times ln of 1 minus x. Now that's the series where all terms are of same sign. Where all terms are of same sign. Okay, so I think we are done with the first one, isn't that? So if I just compare this series with this series, we can say that replace x by, so put x is equal to 1 by 7 here. So just put it. So what will we get? Minus times ln of 1 minus 1 by 7, and the series will be, instead of x, 1 by 7. So 1 by 2 into 7 square plus 1 by 3 into 7 cube and so on till infinity. So we got sum of this first series here, and what is it? So this is nothing but minus times ln of 1 minus 1 by 7, which is ln of 6 by 7 here. That's done. Now the problem is here once again. What is it? It's 2, but the power is 1 less. So what you can do is multiply and divide by 7. So I will be writing it separately. So I will write that series maybe as. So multiply and divide by 7. You get it as 1 by 2 into 7 square plus 1 by 3 into 7 cube, 1 by 4 into 7 raised to power 4 and so on. See, I left a gap in the beginning itself, and the reason is we don't have that first term, so we need to add that term 1 by 7, and since we have added, we need to subtract it at the end also. Now again, so this is 7 into the same series, isn't that bacho? Minus times ln of 6 by 7 and then 7, and then this is minus 1. So let's put it there back. So therefore our integral is minus times ln of 6 by 7, the value of this first series here, and minus times this one. So minus times minus 7 ln of 6 by 7 minus 1. So this is 1 plus 7 minus 7. So plus 6 times ln of 6 by 7. So that's my answer for this integral bachon. So this is how we can solve this integral. So again I will repeat, the importance for me for this question, about this question, was the use of logarithmic series to evaluate such a series, and of course how to take care of box bracket greatest integer function in such cases. Okay, so those were two important aspects I thought I wish to discuss it with you people bachon. So chaliye, we will take up another question in next video then.